Okay, here we have the notes for section 10.6, secants, tangents, and angle measure. So there's our main ideas and vocab. So only one new vocab word this time, secant. So a secant is a line that intersects a circle in exactly 2 points. So a tangent touches at 1, a secant touches at 2. So here on theorem 10.12, you have 2 secant lines that cross inside the circle. So to find the measure of the angles, either 1 or 2, it's 1/2 the sum of the arcs. So angle 1 connects arcs AC, and if you can extend the lines, arc DB. So angle 1 is half AC plus DB. Angle 2 is half AD plus BC. So here we go for example 1 here. Find measure angle 2. Now as this figure is drawn, we can't get directly to angle 2 because we don't know the arcs around angle 2. We know the arcs for angle 1. So we'll have to find angle 1 first. So the measure of angle 1 is equal to 1/2 the 2 arcs that it draws. So angle 1 is equal to 25. Now the trick here, though, is that angles 1 and 2 form a straight line, A to C, which means that they have to add to 180 degrees. And I know what angle 1 is. That's 25 plus measure angle 2 is equal to 180. So subtract the 25. Angle 2 is 155. Okay, so theorem 10.13 is what happens if the lines intersect on the edge of the circle. If that's the case, the angle is half the arc. This is actually a special case of an inscribed angle. So for example, angle ABC is 1/2 of arc BC. Angle DBC is 1/2 arc BEC. So, example 2, find ABC. So before we can find angle ABC, we need to find the arc ADB. To do that, that's a full circle. The measure of ADB arc is going to be 360 minus 102, which is 258 degrees. Now, the measure of angle ABC is 1/2 the intercepted arc. So it is, 1/2 of 258, which is 129 degrees. All right, and the last case is if you have the lines that meet outside the circle, so that either be a combination of 2 secants, a secant and a tangent, or 2 tangents. But in either case, the setup is actually pretty much the same. The angle is equal to 1/2 the difference in the 2 arcs. It's always the larger arc minus the smaller arc. DE is more than BC. DC is more than BC. BDC is more than BC. The one case where you have 2 tangents, these 2 arcs, BC and BDC, have to add to 360 because they make up the whole circle. You can't do that trick on these because you'd have to know at least 2 of the 3 in this case, or 3 of the 4 in that case. All right, so example 3, find x. So this is the 2 secant case. So x is equal to 1/2 the difference between the 2 arcs, larger minus smaller. So x is 35 degrees. All right, so example 4, you're actually looking for the arc. You're actually looking for that distance there. That's x. The trick is that this distance here is 360 minus x, because it's the other part of the circle. If that much is x, this much is 360 minus x. But the equation is still the same, except this time we're given the angle. So the angle is equal to 1/2 the far side, 360 minus x, minus the near side, x. So 1/2, that's going to be 360 minus 2x. So I'm going to distribute the 1/2. 10 is equal to 180 minus x. Bring the 180 over. Negative 170 equals negative x. And then divide by negative 1. So x is 170 degrees. So the satellite can see 170 degrees, almost half the planet. Example 5, which is our final one. Find x again. So x is there on the arc. Now, I know the angle, I know one of the arcs, but I need to find the other arc before I can use my equation. The trick for this one is that WV here is a diameter, which means WRV, the arc, is 180 degrees. It's just half the circle. Diameters cut the circle in half. And then I just go to my equation. So the angle is equal to 1/2 the far side minus the near side. Don't know why I put that there. So let's repeat the half. So 45 is equal to 90 minus 5x. Bring the 90 over. Negative 45 equals negative 5x. Divided by negative 5. X is 9. And that is the end of the section.